All right, guys, so thank you very much for coming to this presentation, even though it's a bit on the abnormal side. I think everyone here knows me, so I'm going to skip the introduction part and go right into basically why I'm studying this, what I mean by the sincere geodesy, and basically what the past 2 years of my life have been about majorly. So in 2018, I started studying things just through my own research, specifically about the Apollo missions. And I reached the conclusion that all of the footage that was released to the public was absolutely manufactured and filmed on Earth. All the movies and pictures we've seen from the Apollo missions weren't real. And it really gave me this philosophy of, well, if that's a lie, what couldn't it be? It's what Jocko's talking about when he talks about the danger of conspiracy theories, right? Like normally when you're starting with someone with a conspiracy theory, you start really small. Start with JFK. Those pictures weren't quite right. So in this presentation, I'm going to make the assumption that the Apollo missions were fake. If I needed to prove that to you, it would be a 6-hour presentation instead of a 2-hour presentation. So we're going to skip that one. We can come back to that if it's needed. In the beginning of 2019, in January, a student of mine, a debate student, asked me if the world was flat. This wasn't emotion. She genuinely asked me, and I was like, no, of course it's not. Give me a week, and I'll explain to you why. And then in July of 2020, I began preparing this presentation. I've spent about 100 to 150 hours just on this presentation alone, but over the past year and 8 months, it's probably been close to 3,000 hours of research that I've spent on this. This isn't something that, thank you, Raj. This isn't something that I'm coming to you and proclaiming lightly. This isn't something I breathed a word to anyone about for the longest time. It's not exactly the proudest moment of my life to stand before you guys and go, hi, my name is Joshua and I'm a flat earther. Yeah, so why is my study sincere? What's different than everyone who's come before me? Why am I so special? I was really trying to study the geometry of the Earth. This is a pragmatic study. This is an empirical study. So I began with the assumption that it was my right to throw out everything before me. I began with no appeals to an authority, and predictable observed phenomena became my only laws. So I want to explain to you my scientific understanding. The difference between a law and a theory isn't whether it's true or not. A law in science, not to be confused with a mathematical law, describes what phenomena will happen. The sun sets every day in Vietnam. Everywhere in Vietnam, every day, the sun will set. We know that. We've observed it for thousands and thousands of years. It's not going to change anytime soon. A theory would be, why does the sun set in Vietnam, but sometimes in Alaska it doesn't? Right. Why is it that for 3 months the sun doesn't set in Alaska? Inside these two, we have what we can trust. We have repeated experiments with successful predictions. I'm going to predict something, I'm going to run an experiment, I'm going to publish it so that everyone can read and see and understand and repeat, and they too will see that my predictions have come true. So here's some example of scientific laws that we all know that we're all going to talk about because it's the nature of the discussion. The sun does set and rise at predictable times, and they're predictable based on the years previous. The seasons do change, and our observation is the sun moves in our sky. As the sun moves in our sky in what we call the Tropic of Capricorn and the Tropic of Cancer, where the sun is on June 21st and where the sun is on December 21st, we know that our seasons change. Solar and lunar eclipses are predictable. They're not predictable because we understand the nature of the universe. They're predictable because every 18 years and 11 days and 8 hours, approximately, there's a couple seconds to throw in there, any eclipse you see, solar or lunar, will repeat itself perfectly. This has been known by humans for over 3,000 years. The fixed stars, since I think that the Earth might be flat, I don't really call planets planets. Planets comes from a Greek word that means the wandering stars. So when I'm talking about the planets, as you've been taught, I'm going to call them wandering stars. And when I'm talking about stars that make the zodiacal lights, I'm talking about the fixed stars. So Leo and Libra and things like this. We know that the moon moves above our Earth. These are all the things that I'm going to be questioning in this speech today. We think that the sun sets because the earth rotates on its axis at 15 degrees per hour, so every 24 hours approximately, a new day begins. The earth orbits the sun once per year on a 66.6 degree tilt. And as the earth is on this side and on that side, that's our explanations for the seasons. That's the theory. A lunar eclipse is caused by the earth coming between the sun and the moon. And that's something really important because we're going to talk about eclipses a lot. But in the heliocentric model that you've been taught since childhood, a lunar eclipse, where we see what's called in ancient languages a blood moon, when the moon goes red, it's because in the heliocentric theory that the moon comes between the sun and the earth. The fixed stars are in fact suns at a great distance, is what we've been taught since childhood. The very closest star is 4.3 light years away, and our sun is 8 light minutes. It's insane. The moon and the sun are in this 400 times equilibrium, where the moon is 400 times closer, but the sun's 400 times bigger. So in our sky, they look the same to us. I'm going to give a quick refresher on what the scientific method is, because this has guided me in my study through the whole thing. Like Jocko said, this is not a debate, this is science. So you begin with an observation of a phenomenon, like the sun sets, and then you question, why does the sun set? And then you imagine. Imagining is good, but mainstream scientists stop there. The next step should be to design an experiment and predict the results. Design an experiment, predict the results. Then you evaluate your experiment, you see if you're right, and you start over. So in beginning of all this, it seemed obvious to me that if we orbit the sun, the earth is not flat. That one seems great. If the earth is moving around the sun, the earth is not flat. So I actually began my research with the very study of what heliocentrism is, with the very idea that we are in a solar system. We are in a system that orbits the sun. My proposition to you is that we might be in a geosystem, and I think that we might be in a geocentric universe. So what holds this big, giant, heliocentric universe together? We call it big G in a mathematical equation. If you've taken even high school level physics, you've seen this horrible half equation, half numerical value many times before. It is the mathematical law of gravity, and it's where our words begin to mix. Because a mathematical law means you can do it over and over and over again on a piece of paper. A scientific law means it's a phenomenon observed. Gravity is a mathematical law in the fact that you can figure out equations with G equaling this, and it will give you the same results over and over and over. But how do we get this? Why do we think that this unobservable, unverifiable, unpredictable constant is a law? We do know that if I drop something, it falls. It's obvious. And we do know that if there's no resistance, it is going to fall at 9.86 meters per second square every time. We know that's consistent. That's a law. Why does it fall down is what I'm questioning. I'm not questioning that it does fall down. So, the assumption that you've been taught, mostly incorrectly, because in high school physics they don't bother teaching you what they actually think. Most of them teach you Newtonian gravity, which is that two objects of mass attract each other in pulsation. So we observe that things are more dense, do fall to the ground, and our question is, what holds us to this ground beneath us? Why is it that when I jump I fall, but when I get in water I don't? That's the question. Newton came up with this hypothesis that objects of mass attract each other. Right? So, giant objects like the sun, which is the most massive object in our solar system, holds the Earth on a string and spins it around by sending waves of gravity through the ether, is what Newton claimed. So what was the experiment? Well, we need to bring two objects of mass near each other. I know you guys have never once witnessed in your life any objects of mass attracting each other except for the Earth attracting you and everything around it. But there was a man who tried to design an experiment to prove him right, and it's a man that's quoted very often. His name's Henry Cavendish. So he comes in with his great balls of liar, as I call it. I'm a big Jerry Lee Lewis fan, so I think this is hilarious, but if you don't get the joke, don't worry. So this was the design of his experiment, and let me give you something a little bit easier to ascertain. Basically, he got two of the biggest boulders he could find, and then got two lead balls, hung them on a pole between each other, then hung a string up to his roof in the barn, and then ran away and drank for 3 days straight while he watched them through a telescope. He did drink for 3 days straight. I don't know how long he watched. His notes are like non-discriminate. He doesn't even give an equation for gravity, but he does claim he got this point where these balls would swing back and forth to each other, and I'm told constantly that this experiment is done all over the world with thousands and thousands of people. I have seen probably 50 plus people do this experiment on YouTube, and they never once get anywhere close to this value. So now for the first time in my life, I'm actually questioning what gravity is. That wasn't something that I expected at the very beginning of this. I just wanted to prove that we went around the sun. It should be an easy job. But what was Cavendish's prediction? It's not the mathematical formula, because he didn't even write math down. It might have been that the balls will swing. That might have been his prediction. And now this experiment's exclusively done by students. I obviously don't believe in the International Space Station, but if I did believe in it, and this was the experiment that gave us gravity, I would assume that in the microgravity environment of the space station, we would constantly be doing this experiment in the most controlled environments always. But we don't. We leave it to students, and it's always wrong, and we tell the students, oh, you did such a good job. You just messed up here, here, here. Now fix your values, submit your paper. Over and over and over. So, I am dismissing what I call a priori, or not what I call, but what is called a priori arguments for what is called an a posteriori. First one would be why you assume an objective truth and try to go out of that truth and deduce things from it, like many of these mathematicians have by assuming that they live in a heliocentric world. The second one is only assuming things you've observed. There are very valid critiques you would make that my study has been too small. I haven't observed enough. But nonetheless, that was my tactic. I started to observe if there was any phenomenon that proved we orbit the sun. I just started to go through everything that I could, and I'm going to sum up probably like a good hour amount of research just in one quote by Professor Ellis. Professor Ellis assisted Stephen Hawking in his publication of the space-time continuum in 1972. He is one of the most respected theoretical physicists still alive, and I'm not claiming my argument stands on his authority, but it did surprise me when I read this from a 1995 publication of Scientific American. People need to be aware that there is a range of models that could explain the observations, Ellis argues. For instance, I could construct you a spherically symmetrical universe with Earth at its very center, and you cannot disprove it based on observations. Ellis has even published a paper on this 3 years later in 1998, titled Cosmological Models. You can only exclude this on philosophical grounds. Now, Ellis is a theoretical physicist. He's not a flat earther. He absolutely believes in the heliocentric model, so he argues that there's nothing wrong with choosing our model of cosmology based on philosophical grounds. And he goes on to say that all modern cosmology tries to hide that we've chosen this on philosophical grounds, and that is a problem, and that was Dr. Ellis's point, and that is what leads me here. Because in my quest of discovering the shape of the Earth, philosophical grounds weren't good enough. But I found out from Dr. Ellis that if I want to prove that we've orbited the sun, the only thing I can do is prove, or assume based on philosophical grounds, Einstein redefined physics with a theorem that says any experiment you do will seem like you live on a flat Earth in a geocentric universe. That's why everything needs to be relative. We'll go into Einstein deeper later. But this teaching protects us, because everything I say to you that there's a problem with and all these things, a moderate physicist is going to say, yeah, but general relativity. Oh, except when that doesn't work, and then they'll say, yeah, but specific relativity. Why is it specific? Well, because the general one doesn't work right now. So in science, we say you make observations. Dr. Mikhail Kaku, who is one of the founding authors of string theory, from his publication, I'm drawing a blank, I think in the 1980s, but this is a quote from a C-SPAN interview in 2010. And he's talking about men in his field. His field is theoretical physics, like Dr. Ellis, like Dr. Stephen Hawking. You have to do a theory, and it's a very tedious process. He argues it's an interview, so he's very emotional. He's like, well, it's wrong. No one I know uses this scientific method. This is not a simple man. It's a 3-hour interview where he explains why they can't, and the answer they can't is Einstein, always. So Kaku is a professor of physics in the Department of New York, University of New York. He's the co-founder of the string field theory, a branch of the string theory, and he's taught at the City College of New York for 25 years. I am not standing on his claims, but they're alarming, as he, with his authority as a doctor in physics, talks about men in his field. Now we go to the ancient philosophers. This is Ptolemy from about 250 AD. He's a Greek, and he's one of the very first people that I can see said that the world is sphere with an original source. Lots of people say Pythagoras believed it, but I can't prove it. You might be able to help me with that, Jack. I know you've said that way more than I have. So the true philosophers, Cyrus, were, I think, quite right to distinguish the theoretical part of philosophy from the practical. For even if practical philosophy, before it is practical, turns out to be theoretical, nevertheless, one can see that there is a great difference between the two. This is touching on the very beginning of what Jack was saying. This isn't a debate. But if we don't start with theoretical philosophy, how can we move on? How can we go anywhere? If we don't start with the very love of wisdom, how can we move forward? I don't think we need to go into that yet. So, but it doesn't matter, right? We know that the earth is a globe. We know the earth is a globe for so many reasons. We know the earth is a globe because we can predict where the stars are, we can predict when the eclipses are, the moon landing happened. The ISS is up there doing things. We've got all these pictures of the earth. We've got satellites doing things. And what about the Foucault pendulum? I said that wrong because I'm not French, but that one that can swing in 360 degrees and show us the rotation of the earth. But why does that work? If general relativity is true. We'll talk about that later. Let's start with star predictions. So I'm going to make some positive claims here. So far, I've only questioned. Positive claims can be proven wrong. Just saying I have problems with things aren't so easy. As I start to make positive claims, there are predictions that can be made and experiments that can be done to prove if I've lost my mind or if something is really wrong. There is no computer software in existence. I've read white paper after white paper that can predict fixed star locations based on the assumption that the sun is the center of the solar system. Not one. Now, to be fair, most of them do assume a spherical Earth, but they assume a geocentric universe in which the sun orbits the Earth, the moon orbits the Earth, and all the stars exist in what is called a celestial sphere. This would be a conceptualization of what a normal program would think, and then you'd tell it where it is, and then it would do a perspective equation to look up. Remember, I'm not yet into whether the Earth is flat. Still, in my research, I'm just like, do we orbit the sun? Please let us orbit the sun. Here's one that's a little more well articulated because it's not for a programmer. It's actually someone teaching a student how to use a 2,500-year-old computer called an astrolabe. 2,500-year-old computer, what? So we don't exactly know where this came in, but it's very clear from writings in China, writings in the Muslim world, and I assume they're from the Persian Empire, but they were kept by religious institutes, not kept by national institutes, so I'm not sure here. But the word exists in all their language from antiquity, and this computer can predict where the stars will be no matter where you are, if you know what day it is. But if you know where the stars are and you know where you are, it can tell you what day it is. It's a completely mechanical computer that lets you line up the date, and each one of these twists right here is a planet. So the gears move in this retrograde motion as they switch through, and all these planets consistently line up, assuming this flat plane right here is the Earth. All computer models that can predict star locations have just taken this mechanical phenomena, represented it digitally, and moved on. It exists in Chinese teaching and Greek teaching and what I assume is the Persian Empire, but I'm not positive on that one. Here's a zoom. This would be where you're standing. These would be the motion of the zodiac. This would be the sun. The back page is the, I got that wrong originally, I'm sorry, these are fixed stars. There's too many planets. I don't know where the planets are in this one yet. This knob turns at a different angle. So this one is for the fixed stars, and this one is for the wandering stars. That one's probably sun and moon. I should have studied this picture a little bit harder. All right, so the next discovery I made was that nobody can predict eclipses at all. Not based on a flat Earth model, not based on a heliocentric model, not based on a geocentric model. All eclipse prediction in the world is completely done by past observation, and I'm going to prove that to you real quick because it's not that hard, but it blew my mind. All of NASA's eclipse predictions are done by this man, Fred Espenak. Every single one of them. He published a book that had 5,000 years of eclipses. All of them were based on that 18-year cycle that I told you before called the Sorrow cycle. And all of them were based on 100% based on observations. The man didn't sit there and do math. He traveled the world and asked ancient people, what were all the eclipses you guys saw? And wrote them down in a giant book. Great anthropologist, just not a physicist. So here we go. From GSFCNASA.gov, all eclipse calculations are by Fred Espenak, and he assumes full responsibility for their accuracy. What? What? When's the last time the American government organizational company assumed full responsibility for anybody's activity? Wow! And so here we go, they're even breaking it down. They're like, all right, we don't even know. The predictability and recurrence of eclipses is governed by the Sorrow cycle, invented by the Babylonians in 2000 BC. And NASA still needs to use that. So I want to look real quick at something really specific. This is what's called the Great American Eclipse. It happened on August 21st, 2017. And it began over the Pacific Ocean around 3:45 GMT. The sun's shadow started in the Pacific Ocean and moved east over the Earth. I want to clarify that, that's an important part. So it started by Washington and moved east to Florida. Second, there's a shadow. Right? So, that's 3:45 GMT Thailand, just was in Vietnam, so that's the setting. This is solar system scope. They're advertised on NASA's website numerous times. They're one of the most accurate star prediction heliocentric universes. They're free online. And here I am looking at the beginning of the eclipse, and you might need to come forward to look at this, but we see the moon there, and we see Florida there, and now let's go forward a little bit of time. We see the Earth rotating. Now we see at the very end of the eclipse, the Earth has moved into position so that it would have been cast exact opposite as it progressed in 2017. If you need to come forward, please do, because I know it's very hard to see the North American outline in this, but if you'd also like, I can pull it up live and we can watch this again. We can go back to this time. It's there, it's on the internet. You can use different scope, you can use anything you'd like to look it up, but I swear to you that if what they're telling us is true, then the moon's shadow should have started in Florida and ended in Washington, but it didn't. We can check this again. This is from timeanddate.com. Here we can see the time, 1639 UTC, 1703, 1731, 1803, 1839. I'm counting up, not down. That's not even talking about what a selenium eclipse, it's such a hard word to say. A selenihelion eclipse is an eclipse where you see the shadow on the moon and you see the sun in the air at the same time. This has been recorded by ancient times, but we don't talk about it too much now because it kind of disproves the whole theory. I did some, it seems like the French made this word up, but the roots come from Selene, which is Greek, that means moon, and Helios, which means sun. Like I said, it's not something NASA's super open about. In their entire website, they have 3 references of this eclipse, and it's actually user-published content from eclipse newsletters that they stopped in 2005. Luckily, the archives are still there. This newsletter just mentions that in one of the astronomy books in the UK, all mention of Selenian eclipses were removed. It's not so important to my take. I would like to look at this. Like I said, it's not something that's very published in mainstream science, so it's not something we see a lot of. But nonetheless, here is one. We see the sunrise, and it's a beautiful sunrise too. He's on the top of the mountain. And I love taking pictures of the moon, so his moon photography frustrates me so much. But he does show it. I wish there was more documentation. It seems New Zealand experiences them more often than the rest of the world, so they, or at least they're more public about them. Almost all publications I've seen have been from New Zealand press, but this guy actually hunts them. He's just a photographer, he's not a photographer. He just likes it because it's amazing. So he's going to wait until the sun's in the sky, or maybe on this one he doesn't wait till the sun. And then he shows mid-eclipse. Oops. And if you're going to argue that it's the phase of the moon, you should be aware that if the moon is 180 degrees from the sun, the moon is always full. He's found 210 years. It sounded a bit different when he showed you the moon first and then zoomed in on the sun. Like I said, I start with questions, but I keep going. I'm not ready for that yet. So the moon landing, I don't really have time to go into all my evidence for this, but we can take that offline if you're interested in the Apollo missions. Just some really basic reasons. I've gone through all of the footage from all 17 supposed landings, including the footage of Apollo 8, 9, and 10, and I don't believe any of them happened. First one, most obvious, when Nixon talked to Neil Armstrong on the phone, he talked faster than the speed of light. He literally responded faster than the speed of light. Couldn't have been on the moon because that's 250,000 miles away in the mainstream etiquette. The descent engine can't be heard in the radio communication when Apollo 11 lands. It's a 40 kilonewton squared engine. It's a giant rocket engine that lowers them safely to the ground. And Neil Armstrong's talking like, all right, about 1,000 meters, about 200 meters, 200 meters, 50 meters, okay. Not a single thing can be heard. Nonetheless, when Buzz Aldrin handlers in the core tubes in Apollo 12, you can hear that. But it's a vacuum, so we shouldn't be able to hear anything. There's no burn marks under the lunar module from that giant descent engine that I just talked about. How did they spill orange juice on the pictures in Apollo 15 in a vacuum? And I also don't believe that a flexible pressurized suit could even survive in a vacuum. I think it would fully expand and you wouldn't be able to move, because everything I've observed in the vacuum does exactly that. And I also don't think an 8-inch wall of aluminum foil is going to hold back a quarter of a bar inside an infinite vacuum. And if the Earth is a globe, there are these things called the Van Allen belts that completely surround the Earth in radiation. That would kill anyone anyway. ISS positive claims. I've watched so many hours of ISS people answering children's questions about how do you go to the bathroom in space. I don't think that no human being has ever lived on there at all. But there obviously is an object shaped like the ISS above the Earth. You can take pictures of it traversing the sun and the moon, which convinces tons of Americans, but the odd thing is you can only do it in certain countries. Never once has it been visible in Vietnam, ever. And it never will be, because whatever technology they're using to cast it up, they don't have permission to fly in all countries. There's literally a place right over the border in China that you can see it, but in Vietnam, magically, or 2 miles over, it stops being visible. I don't know what it is, but it's not a space station. And here's definitely, most of the pictures you've seen of Earth, NASA will admit to you they're Photoshopped. They'll just come out and say it. They'll be like, oh, they're not Photoshopped, they're images. Apollo 17, I don't think it happened, so like it's just a photograph of a marble. The one that was on the iPhone, that world that everybody knows so well, oh no, I'm supposed to have 2 pictures here, was done by a guy named Robert Simmons. I thought I had a picture on him, but oh well. I guess I don't. And most of the other ones are fisheye lenses. Here's a phenomenal example of the magician and wizardry they can do with a balloon and a fisheye lens. You think that this picture is done by the ISS, right? And you think that this curve of the Earth is because the Earth is a ball. But let's look at what we're talking about here. That canal right here is that. Oops. I'll come back. It was such a good point. Told you it's a conspiracy. So sure, this doesn't prove that the ISS doesn't exist, but it does definitively prove that the pictures they're showing us don't even match their model. What about the Red Bull jump? Everyone remembers the Red Bull jump, right? This guy, there he is at 40,000 meters in the air. He went up by a balloon, not a rocket. Here, you think a rocket would be quicker. The balloon that he needed was bigger than the Statue of Liberty to take him up this high. And here you can see before he gets out with a flat horizon all the way through. And then they're like, no, it's a ball. See, this is our GoPro. And I just want you guys to do it for yourselves. Like if it was a ball, keep drawing the circle. There's no ocean in this picture. If that was the curve of the Earth, what country is this? Certainly not California. Same thing. Oh, and then look, the Earth curves upside down. And it does it again. We gotta stop showing that picture, right? And then he gets out, and it's perfectly flat. We see this often in media. This trickery. Come on. I might have a freeze. We see this often also in a popular TV show called Mythbusters. We see Jamie going up in a YouTube plane. YouTube's really famous because it can go 70,000 feet, like 25,000 meters in the air. So very, very high. One of America's highest planes, despite the fact that the Russian MiG could do it 40 years ago. So we see here that at 5,000 feet, we've already got a big old nice curve on the Earth. Then at 10,000 feet, we've got a little curve, but it's a little bit less than at 5,000 feet. And at 50,000 feet, it's the same. And then, they're tilting down so that the angle gets a little bit more severe. They haven't gone anywhere. They're just tilting because they're using a fisheye lens to make it look curved. It's at this point that the guy in the pilot seat goes, yeah, you can see the curve of the Earth now. And then it tilts to his face with a perfectly flat horizon behind him. Because they don't use a fisheye on people's face. It makes them look fat. Nose cam, oops, still straight. This one's kind of straight, and then they tilt down for you. But then face cam, perfectly straight. Once again, starts in the middle of the lens because the way that the fisheye wide-angle lens work, if you keep it in the middle, it's not distorted as much. But then when you tilt that same picture down, you've got that round again. And at this point, they're just talking about it over and over. That was a terrible circle. That's not a fair point. Yeah, it's not. It's deep in my animation, so that one didn't get fine-tuned. But then once again, we can see the back cam with a perfectly straight horizon. Not that this is my proof, but this is evidence that the pictures we're seeing are not manipulated. Or excuse me, the pictures we see are manipulated consistently. That's the episode information for the Mythbusters. That's not important. There's this guy who's an amateur balloonist, and he's been sending balloons up for about 4 years, and he is careful not to use fisheye lens, though all lenses do some curving. He's really specific. He publishes all of his lenses, and he's really just trying to get honest footage. And here's him at about 120,000 feet. And you do see some curvature there, but it's a whole world of a difference from what we've seen before. Another pretty strong one of some good footage here that's less altered. Like I said, all lenses will curve. If I took a picture of a perfectly straight line, it would have some curve to it because lenses are in fact round. But we see something pretty different there. Or satellites. Right. So the real question here is there any technology that's in use? I approach this like an engineer that proves the existence of satellites. Is there anything that they're doing that balloons couldn't? Our balloon technology is absolutely unbelievable. Like I said, that's what brought the Red Bull guy up 120,000 feet. Military uses balloons and kites for communication like nobody's business. There's a helium shortage on the world, not because of global warming, but because how much America is importing. And our biggest consumer of helium does happen to be NASA, oddly. So there's real coastal limitation to satellite phones. And if you ask a sailor this, he can confirm that for you. When you're in the depths of the Atlantic or the Pacific Ocean, your satellite phones stop working. Mounts for an airplane and a satellite phone go under the fuselage, not over. I'm pretty convinced that maybe in some severe cases these are balloons, but I'm pretty convinced these are all land-based communications. And there's really no reason why they can't be, and I'll go into that in a minute. Here's NASA's page on their balloon development. They really are one of the leaders in, it's not just weather balloons. Like there was a satellite that Samsung sent up when they were taking pictures all over the world that had a mishap and landed on someone's house. And it didn't look like anything with wings and solar panels. It was a box attached to a giant balloon. Like, there are provable lies about some satellites being balloons. And there's no technology that I can find that proves that we have satellite. Source for the helium consumption of NASA. And most people go to GPS. And wouldn't every engineer at every GPS manufacturer need to know how GPS works? And if the private sector developed that technology, that would be true. But in reality, the U.S. military developed all GPS positioning. And then in 2000, I thought it was 1999, Bill Clinton released APIs to the public. So basically, he just released a language and addresses that the public could tie into to use GPS. But they still don't work in the middle of the sea. So all you're doing is you're following what the U.S. military declassified, and everything on the other end of the technology, none of these engineers understand. They just read what's provided to them. Or it's this. That's an actual count of a simulation of how many satellites that should be in the air right now. I've stared at the moon for hours. All these should be between us and the moon. Right, we can't see them, but we can see the ISS, don't we? Even though it's only the size of a Boeing, and when we see it on the moon, it's the same size as a Boeing that's at 30,000 feet, but this is supposed to be at 500. So what about the Foucault pendulum? Please let the Foucault pendulum help us. We've been told that these pendulums that swing on a 360-degree axis are around the world, and they prove that our Earth rotates. And I was like, fantastic, let's do it. So they say that, as it swings, if you watched it for 24 hours, you would be able to know what latitude line you are, how far north or how far south. Because as it swings and the Earth spins under it, the pendulum should slowly start to do this, because it acts like a gyroscope. So they say. So I was like, that's it. I got to make one. Boom, I proved it. The Earth spins. The Earth's a ball. We're done. We're going. Let's do it. And then I found out that everything online says, well, if an amateur makes one, they don't quite work. I was like, but I've seen one. I've seen one before. I've seen this one that was removed from the Smithsonian Museum in Washington, D.C. in 1998. I saw it before it was moved when I was like 6 or 7, and I remember because it blew my little mind. But it still needs to be started. And then I discovered this patent from 1969, before any of the pendulums were in museums in the U.S., that talks about this magnetic motor drive that keeps it going the right direction. It's not a very good phenomenon if I need a motor to keep it going in the right direction. And then I found out that even at the Smithsonian Institute, there's a donut-shaped magnet by the joint to give it a kick in its natural direction by their own admission. And I was devastated. Kick in the natural direction. So there I was, at the end of about a year, just trying to figure that we were orbiting the sun, And I came into this logical cycle of unsuredness that I still exist in today. If the world is a globe, then we orbit the sun, obviously. And if we orbit the sun, then the Earth does rotate at 15 degrees per hour. And if we rotate at 15 degrees per hour, then general relativity is probably true. And if general relativity is true, then obviously the world is a globe. I only need to prove one of these as these assumptions and assertions rest upon each other. But we do know, right? We've known for hundreds of years that the Earth is a globe. This is silly. We don't. Here's a paper declassified in 2011, written by the KGB in 1948. Sorry. Release date, 2011. Subject, scientific Earth measurements. Oh good, they're studying Geodesy too. That's what I want to do. We want to measure the outer gravitational field and shape of the physical surface of the Earth. In 1948, the KGB is trying to measure, like we knew that already, I thought. Surely we knew this already. I have sources all the way. This is from CIA.gov. A study is made of the conditions necessary for the solvability and uniqueness of solution of the integral question by the aid of which the outer gravitational field and the shape of the physical shape of the Earth may be determined. They didn't even know where to begin when they started this research paper, because they were trying to take all these different models of spherical Earths or models that their own scientists have done and wrap them around an ellipsoid like they were told to do. The system now adopted for reduction of a geode, which is a fake shape, and it means the shape of the Earth. Okay? So that one can't be wrong. Right? Like a square is a fake shape with 4 perfect 90-degree angles. A geode is a fake shape that means the perfect shape of the Earth. So this doesn't mean sphere. Attention. It has possible inherent contradictions, since various parts of the terrestrial gravitational field are reduced on basis of different hypotheses which are sometimes contradictory. Every time we turn the geode from all of our maps into a ball, everything stops working. And that was the purpose of this paper. And if you turn your results into an ellipsoid, it can noticeably reduce the accuracy of results. Even with exhaustive geological data, a sufficiently accurate reduction to the geode is connected with solving a complicated problem in the theory of potential, because the reduction is carried out on an unknown surface of the Earth, on which limited values are determined directly by observation. So in 1948, the Russian scientists, they weren't Russians, they were Nazis. The Russians stole Nazis like we did. The Nazi scientists wearing Russian hats said that after all of our studying with V-2 rockets and the Kaffenheim-Greiden system, we still have no clue what the shape of the Earth is. At least I'm not alone. I'll skip these for time. They're just saying they're still confused. So this would be the calculation of wind compensation for the launching of unguided rockets. Remember, the Foucault pendulum changes because of the spin of the Earth and all that. And you've heard the Coriolis effect where snipers need to compensate and then the water spins and the hurricanes and all this crazy stuff. This is where I'm getting this from. This is NASA as can be. And let's go into it. In addition to the above requirements, this is a simulation, but this simulation assumes a vehicle with 6 degrees of freedom and aerodynamic symmetry in roll, and the missile position in space is computed relative to a flat, non-rotating Earth. That's concerning to me. You're right, it's just a simulation, but if any of the phenomena we've been told to observe are true, then it would be a useless simulation. Determination of angles of attack and side slip from radar data. So let's talk about this. Let's talk about jets that are going faster than the speed of sound. Let's talk about the fact that they're covering 500 to 1,000 kilometers. About 30 minutes, about 25 to 30 minutes. Right? And also keep in mind that normally when an American pilot gets noticed that something's on its radar, it's about an hour away. It's about 2,000 kilometers more. You must talk 4,000 kilometers. 1,000 kilometers of Earth should be 75 kilometers of curvature. As you go 1 kilometer, 1,000 kilometers out, you should already be in space. How do the radar waves? Sorry, I didn't highlight this one. Equations for angles of attack and side slip relative to both a rolling and non-rotating rolling body axis system are derived for a flight vehicle for which radar and gyroscopic altitude data are available. This method is limited, however, to an application where a flat, non-rotating Earth may be assumed. How often can we assume that? And how high until the jet needs to be in which he sends radar waves in a perfect circle, spheroid even, around him? What, does this only work on the landing strip? Is this a paper by NASA to calculate how the angles of attack of their radar system works on the ground? I don't think so. I really don't. So let's talk about Marconi. Marconi in 1901 sent the impossible signal. He's the guy that invented the antenna. His boss was Hertz. You probably heard of him because it was like 10 Hertz, right? He invented the antenna and he's like, dude, I'm going to solve all the world's problems. Let's go big or go home. And went from Ireland to Newfoundland, Canada and sent a signal. And he did it in 1901. And everyone's like, no, you didn't. That's impossible. Here's the ball, dude. And so he's like, all right, let's try it again. And so in 1902, he enrolled the help of the captain of SS Philadelphia, put a receiver system on the boat, put his own engineer on the boat, and sent him new messages every 10 minutes as the boat went from Ireland to Nova Scotia, and both the guy in Canada and the guy in the boat received the message the entire time. This is 1902. There's rumors that he sent one to Australia, but I can't verify it, so I won't go into it. So let's think about that. That's a 3,500 kilometer difference, and that should be 940,000 meters. This should be 934 kilometers of the Earth going around, right? So, you guys have probably heard of the ionosphere before. The ionosphere was invented about 30 years after this guy, as a physicist, was trying to explain why what this guy did was possible. He took the assumption that the Earth must be a globe and there's no way to be fallible. And then he said, well, the signal must have gone like this off of something. So he invented the ionosphere to give it off of something. He wasn't a radio engineer, so he didn't understand that every time a radio signal bounces off something, it goes down to 25% of the signal strength. And there is no way, in 1902, they had a receptor that could have survived the 7 bounces needed, going down to 25%, 25%, 25%, 25%. And why did the SS Philadelphia get it the entire time without reception? Why does this picture exist? This is the picture of the Chicago skyline all the way across of Lake Michigan. It is 91 kilometers away. This was taken by a guy named Joshua Nowicki. He's not a flat earther, he's just a photographer. It's a regularly observed phenomenon. It's over 91 kilometers away. The tallest building in Chicago, which is this one, the antenna on top is 527 meters. The Earth should curve away from Mr. Joshua at 653 meters, bearing this antenna by over 100 meters. But it's just a mirage. A mirage that's a shadow too? Neat. How is it that it would be a superior mirage reflecting these buildings right side up, even though mirages are upside down, when an inferior mirage of the sun is still visible at the same time? I can see the sun under the buildings. There's your mirage. These are real. How? All right. I need a second. I need smoke. I want you guys. It's actually a manufacturer of a pet camera. You'll be able to see their name in just a second on the sign. Pretty soon, once they get closer to the stars and the sun, you'll see their name on the sign.
Shouting and just being awestruck about what he was seeing about that video we just watched. Talking about the sun. I don't know if you noticed, but there's a lighter spot underneath the sun, which isn't how light works. It's really small light, and you have the sun is so far away. It should not have hot spots. Yeah. But in that video, I don't know if you saw if you were paying attention to it. I was, because we surrounded that 5 times. Point to that bit. Yeah, do you see that? Is that? How is that possible?
Really? Wow. That's just wow.
Wow.
Because literally in Vietnam, you can see that the sun
That
is
is
going
why
down.
you can't offer. That's why I was at Fusion, actually. I was trying to record that. And then, yeah, when I was in Blue Town, I was trying to record that sunset. But the clouds over the west would show that I couldn't record sunset. So I started recording, I realized I could see 95 kilometers away from the Maycomb. So I started, I was on that hotel, trying to sunset. When you keep going back to Blue Town, that shot. I want that shot.
And also, I don't understand about the part that the sun and the moon like appear at the same time. So what was
So
it
it's
about?
together. So maybe you have to talk about this as well.
Yeah. It's a lunar eclipse.
Because I really see that really often.
No, it wasn't the fact that they're both in the, it wasn't the fact that they're both in the air. So,
Good as always, thank you.
right? So a lunar eclipse happened.
I got one guy actually.
But
When
how
you're-
about if I see it, but like it doesn't have any eclipse at all?
Then it's not so rare unless it's a full moon.
Oh.
If it's a full moon, it's really rare and like call me and I want to get out and see it too. But in near the new moon, when the moon looks like this, it's right next to the sun in our sky. So when the moon is like a fingernail end, it's normal that it's in the daytime sky.
Later?
Yes.
Huh.
Bum ba dum. Let us. One more thing, right?
The moon in the daytime? What?
You've definitely seen the moon,
Well, yeah.
but never a full moon.
Well, yeah. It's not very like round shape.
Correct.
at all, but
Because when the
I can
moon is
see
a
it.
full moon, it should be at 180 degrees distance from the sun.
When at first I see it, I thought I saw that in the morning the moon came down already. But
So
now I
right
see it.
now, the
Actually,
moon
I saw it.
is completely invisible, right?
Huh? Say that again?
Right now, the moon is completely invisible.
Right now, invisible?
Control shift.
Well, we could wait at this point.
No. She's just asking a question. I'm trying to help her understand, but I messed up on my.
Waiting
Give me
over.
1 second. All right. So yeah, it's invisible because it's a new moon today.
Oh, is it an app?
Yeah. So see the moon as a fingernail. So tomorrow the moon will be. Look at the day, August 22nd. There's Vietnam. We'll be able to see the moon and the sun at the same time. This is how it moves from our observation.
Ooh, it's changed the shape.
Of course. Look at the day. Look at the day.
Wow.
Right. So as the moon gets farther to 180 degrees to the sun, the moon will get bigger and bigger and bigger.
Ooh.
And once it's at 180 degrees from the sun, the moon will be full.
Wow. Amazing.
So once again, this is Vietnam. Here you can look at the time. That's local Vietnamese time.
Who invented that anyway?
A Greek guy. Ages ago, like he didn't make the app, but the guy who made the app, it wasn't his idea. And that's what you see. So the question would be, during an eclipse, when they're at perfect 180 degrees, how could the sun be visible and constantly be, also be blocking the, also the Earth is blocking the sun's light to the moon. There it is. That's the statement. I'm not gonna let you guys run out of beer. That'd be crazy. You'd leave. At this point, when I'm in, like I said, that cycle where all these different explanations all hinged on each other, I started this walk backwards through history, and as my understanding of mainstream science, heliocentrism, and history is, this is how I draw that presentation. So Einstein stood on Newton, who stood on Kepler, who stood on Copernicus, who stood on Ptolemy, who we're told stood on Aristotle, probably did, and then who stood on Pythagoras, which I don't see any original text evidence from, not to say that it didn't happen, I just think it's all lost. And you might say to me, but this is a very singular focus, why are we only looking at the West? So I'd like to make a quick divergence into Chinese astronomy, because we do know that Chinese astronomy was far superior to Western astronomy until only very, very recently. Even the words, when you study them in Vietnamese, it's interesting that the word for the force that makes something fall to the ground and the word for the force that holds a satellite are different. The difference between the different forces. So here's one source I found, not super reliable and super hard to read, but it's a Modern Mechanics article from 1931, and it reads that China, which had workable systems of astronomy as soon, if not sooner, than Greece or Egypt, continues to stick to the flat world theory. So that's interesting, but this is 1931, so I couldn't prove that. As I started to study the origins of Chinese astronomy and why they believed in a heliocentric global system, I found it all led to the Jesuits, surprisingly enough. Yeah, you thought I was going to say the Jews, didn't you? No, it's the Christians. So, in the 17th and 18th century, in the course of which Jesuit missionaries came into contact with the Chinese elite, they witnessed a succession of radical scientific changes whose powerful echoes reverberated as far as China. What an interesting beginning. Let's keep going. The Chinese imperial authorities would not have entrusted missionaries with the task of reforming the calendar, and even less appointed them to head the Imperial Bureau of Astronomy. That's interesting. My point here isn't why they did it. I'm going to go into that later. My point here is that they did do it. And this is a biography written by a Chinese astronomer named Mai Wengding, who fought against the Jesuit influence and is specifically talking about their lack of empirical evidence and their consistent dependency on theories that have never been proven. And so even when the Jesuits tried to put everything in, the point that I want to make here is that they were made to re-edit works of European origin because the Chinese community was just rejecting these works. And they were saying that they could not suppress the absurdities here contained herein. The criticism leveled at the Jesuit trustee was aimed at the fusion of cosmology and celestial spheres. And they looked at that as the same kind of teaching as Christian theology, where it's all based around a pure lack of empirical data, and it's all about how I feel and what I want to be true. The idealized space of geometry, subservient to deductive logic in the Euclidean way, seems as superfluous to Chinese mathematicians for the mastery of astronomy as celestial space accommodated to theology. Now, to talk about that, I want to talk about the difference in the Greek thinking between cosmology and astronomy. Astronomy is math. It's what we see in the sky. The stars do move. I'm not arguing they don't. They obviously do. And how we observe the lights that move in the sky and when they come back and when we know they'll come back and how we know where we are based on what they look like is the study of mathematics in both time and space at the same time. The Greeks thought that there were 4 types of math. The idealized math, arithmetic, math in the abstract. And there was math solely in space. It's geometry, right? But the Greeks didn't study it on paper like we do in abstracts. They built things. Then after that, they studied mathematics in time, and that's music. You know how the beat keeps. And then finally, after you studied those 3, you were ready to study mathematics in time and space at the same time. And that's astronomy, as it moves with the time and as it moves with the geometry of where you are. Then, once you have studied the 7 subjects of the student, Plato labeled the trivium and the quadrivium, you were allowed to begin to enter philosophical studies, not before. Philosophical studies are cosmology. What is the earth? What is the sun? These are philosophical questions. And sure, if we went to the moon, there would be way less philosophical questions, but we didn't. And we can have that later, I guess, long. But we didn't. So if we've never observed this, if the Van Allen belts really do lock us in, and I can consistently show in evidence of a lack of curvature, then we must still think about these as philosophical and as mathematical and different as the two, which was Dr. Ellis's whole point when I began this presentation with one of the most renowned physicists still alive. And it was his whole point. Considering the Chinese rejection of speculation verifiable by expedient of dogmas and axioms, the Chinese said, if you can't prove it to me, get out of my face. You're like, but no, we know it's true. And the Chinese astronomers as a whole weren't interested in cosmology. They attached a limited importance to cosmology. We don't care what the sun is, we care how our crops grow. And when the sun's there, they grow better. We plant when it's here. We harvest when it's there. We have moon cakes. It's wonderful. In Renaissance Europe, mathematical astronomy formed one of the 4 mathematical arts of the quadrivium, which is what I was referencing. I don't know how they call ancient Greece Renaissance Europe, but carry on. Whereas physical study of the heavens was the concern of natural philosophy. Meaning we educate our children what the sun does before why it does it. But if all of you think back to your own education, you saw the globe when you were 2 or 3 years old. Before you could dare ask the teacher, why don't I fall off? If for the first time in my adult life someone came to me with the heliocentric theory, and they didn't have the Apollo, the International Space Station, to fall back on, what would they dare start with? More about their problems with Christian theology. But the main point, the German Jesuit missionary John Shaw went to China as a missionary in 1618, and he went to Peking in 1630 to undertake the reform of a Chinese calendar. What a position acceleration for a humble missionary. Shaw, rather than just assisting, was put in charge of the production of a new calendar. It was in 1645, and this was the very first time in any Asian astronomy or cosmology anyone dared to suggest the world was round, let alone the heliocentric universe. So I'd like to go back to my Greek philosophers because the Chinese were bullied into taking it, Greek and European. I really do defer from the consensus, and this is a major positive claim that I'm making, and this really is the crux of my point from a modern mainstream physics point of view, but it's hard to explain to people because nobody has taught Einsteinian physics. And so Jocko nodded in agreement when I said earlier that I need to talk to people who've already studied what I'm explaining, and then you go into it, because high school physics and 100-level college physics teaches you Newtonian physics, which stands in direct opposite of Einstein. But I think that Einstein's brilliant theory or theories are not abductive but deductive. They did not lead subjective realities into objective truths, which is what abductive reasoning does. And he didn't focus anything on his own observations. And abductive reasoning is more a little bit of a gut feeling, but definitely some empirical observations. But rather the infability of the people who came before him. He assumed that those who came before them were correct. And so he made his decisions based on philosophical grounds. And with gross assumptions in hand, and all observations showing the contrary, he mathematically proved what we could never observe, a priori. My name is Einstein. So if I don't trust Einstein's general postulate that if heliocentrism is true and if gravity is true and it's a ripple of the space-time continuum, then everything you observe for the rest of your life will be as if you are on a flat, non-rotating plane, not to quote NASA. Let me go before that. That is what Einstein postulated. Before that, we have Newton. So I'd like to take you to George Airy. He did this ether drag test. So remember, right now, we are taught that space is actually a ripple in time. Or excuse me, gravity is actually a ripple in time. That is what Einstein said. What you've been taught in school is that objects of mass attract as a wave goes through. Waves need something to travel in. Like a wave can travel in water, my sound can travel in the air, the light. What does light travel in? Einstein said that light was a particle, a thing that we can touch, and a wave at the same time. There is no a posteriori, there is no observation or empirical evidence that this is true, unless you assume that the Earth is a globe circling the sun. But here's a phenomenon that was used to test this. So the assumption was in Newton's era that there was this thing that existed everywhere, even in space, called the aether. And that's why this is called the aether drag test. This was the medium that light waves could go through, because the assumption is sound waves go through air, water waves go through water, light waves go through the aether. Einstein said there is no aether, there are no waves. But Airy was trying to prove that there was an aether, and he was doing this with a phenomenon known as stellar aberration. And perhaps you guys don't know this, but if I had a very long telescope and there was a star directly above me, and I lined that telescope up with the star directly up and looked in, I would see no light. I would not see the star. The star would be completely invisible to me if I was not at a 5-degree tilt. The reason did that work? The reason is, in theory, that the telescope is moving on the Earth and that the light waves are falling into it. In Einstein's theory. In Newton's theory, it was that we were moving through the ether. And the light was moving through the ether, so it's just like this idea where if you were driving through the rain, it would feel like the rain's coming at you, right? It'd be really hard. Same kind of thing. But the question was, from Airy's point of view, was it the object moving or was it the stars moving? We know the phenomena exists. We know you must tilt the telescope because the light does come in like this. And if the telescope's in motion, tilting it allows the light to go through. Straight up it doesn't. We know that. So Airy, trying to prove this, designed an experiment, saying that if the Earth is in motion and the light is a constant, then I should be able to fill my telescope with water and change the angle, because we know water slows down light. So if it's my telescope in motion and the light in the barrel is being hit into the side by the telescope moving, then filling the telescope with water should slow it down enough to give the receptor of my telescope. But if the stars are moving, then it should be the same. And so his prediction was made that he would need a 10-degree tilt instead of a 5-degree tilt out of water. This is known as Airy's failure. So all mainstream scientists took this to mean that Newton was wrong, but with the general theory of relativity and just enough specific relativity to make it work, Einstein proved that this is okay. Here's another question. This is James Bradley. This was actually Airy's teacher. And he was on the hunt for what's called parallels. So I want you to think about this. If the sun is the central point of our orbit, then in June and in June and December, our Earth should be on completely opposite sides of the sun. Therefore, the angle with which we view a star should be completely opposite. Because if this is the straight up tilt, then our viewing angle 6 months apart should be once that way and once that way. It's not though. It's exactly the same. And this is when we started getting into the theories about how the stars are so far away that it's beyond compensation, and that somehow, even though a light reduces by 25% for every double in distance, and the sun's only 8 minutes away by light speed, and the stars are 4.3 years away by light speed, they're still visible. Sure. That it's just they're so far away it doesn't work. Trust me. So they went into these two guys, brilliant guys, Albert Michelson and Edward Morley, which once again, the reason why their experiment failed was Einstein's general relativity, right? But you still can't prove that one to me. So anyway, they designed a brilliant experiment where they've got this light source and they've got a half-silvered mirror so that some wavelength will bounce off the half-silver and some won't. Then they've got another mirror here and another mirror here, right? And they're bouncing all these lights off of each other and they're running it in, and then they're going to do it in every direction to try to prove that the rotation of the Earth is making the light move. It's basically Airy's experiment on steroids. They're like, Airy had so much he didn't account for, he's right. You can buy one of these setups for $3,000, $4,000. And so like this is what it looked like. This guy's splitting little beams, and then they're going to spin it so that it faces the equator, it faces against the equator, and they're trying to see the light lag behind the Earth as it spins. But it failed. Light didn't move. Nonetheless, we're taught that we're orbiting the sun as it orbits the galactic center, as the solar system orbits a black hole, and we're told that a 2,500-year-old computer can predict the location of every star, but the Earth spins at 1,670 kilometers an hour, and it chases the sun at 107 to 108,000 kilometers an hour, and the sun orbits the galaxy at 828,000 kilometers per hour. But every day we witness absolute finite stillness wherever we are. Because none of these mathematical equations work unless you assume a flat, non-rotating plane. This exists. The vacuum pressure of your lungs can pull water out of your glass against gravity, but the infinite vacuum of space can't handle the gradient of our atmosphere. Show me one time observable on this planet. You can use the Earth's gravity if you must. Show me one time where you can have a pressurized system next to a vacuum without a physical barrier. Show me one experiment, one guy who can prove this, and I can reproduce it. So if Einsteinian's theories is wrong, Newton didn't even believe his own theories. That's why everyone was trying to prove the ether. Kepler never left his room. Literally, he took Copernicus's writings that the sun was the center, and Copernicus's writings were terribly flawed. He thought the sun was the center, and we all orbited perfect circles. And everyone's like, but that's not what? No, that doesn't make any sense. So Kepler, a mathematical genius, just sat there, assumed Copernicus was completely right on everything, and it made the math work. That's not good enough. I don't care about the math. I know the math works, unless you need to predict every star, and then you go back to my theory because it's easier. Copernicus, the Jesuit priest, couldn't even account for a single planet's motion, let alone anything else. So there we are, Ptolemy, Aristotle, and the Pythagoras, and I went back to the ancients because they have everything I have. They can build everything I can build. And I've been told since I was a child that we've known the Earth as a ball for thousands of years. So there should be nothing the ancients have that I don't. Nothing. Milkus and Molly, if I want to buy that laser experiment, it is about $3,000. I'll do it eventually. Give me time. Wait till silver goes up. So Aristotle and Ptolemy had 4 reasons in their writings why they thought the earth was a globe. Oh, hold on. I'm going to explain why I went straight to Ptolemy. There's no original text evidence for Pythagoras, but there are tons of text evidence of that Pythagoreans, his disciples, his followers, believed the globe. And Jocko studied Pythagoras way beyond I have, so he actually might be able to point me to something contrary to this, but I haven't found it yet. Aristotle and Ptolemy were both geocentrists. Aristotle's writing on cosmology is questioned whether it's original by a lot of scholars, and Ptolemy's is almost identical, so I didn't feel the need to go into both, so my focus fell to the original Greek writing Almagest by Ptolemy. Why did he think that the earth was a globe? So he said that the sun and the moon and the stars do not set simultaneously for everyone on earth. That's not a very good point. We know they move. Mountains appear top first on the horizon. When sailing towards them, it's the same thing that's mentioned in reverse by Aristotle, where ships sailing away disappear bottom first. And this was one that sent me into 3 different physics courses from MIT on light. It was insane. But the phenomenon is called angular resolution. And I should be able to demonstrate it quickly here. MIT puts their light physics courses for free on YouTube, so anyone can watch Professor Julian's 400 hours of lectures. But basically, as it stands, I'm observing something. So as I stand here, my eye needs to receive light from all the way up on here. And the light gets cast to me like this. The light would get cast to him like this. And even further so on the extreme, the light would cast to him like this. So right here at my same eye level, I have all this land competing in my eye for the same territory of light like this. My eye can only see light as it goes into it at a certain wave angle. And as it gets cut off here, my eye just rejects it. The most beautiful example of that would be this. So right here, this is emitting light at a frequency that your eye just can't handle. It's outside of your angular resolution. My camera can handle it without a problem. Maybe that.
You see?
No light.
I always like straight.
No light. So infrared is a light, it's a resolution that you can't see, but my camera can, so it's just going to represent it as purple, because that's the closest on the spectrum. Right? So what's happening here is all this light is competing for integrity in your eye, and the angle is just getting superseded. And I made a prediction. Oh, this is original text saying the same thing I've already said. So I made a prediction. I need to be able to make objects disappear bottom up over a flat surface, and then I need to be able to cause the object to reappear without elevating myself, but rather by changing the lens in front of the observer so that the angle of the light would be changed. And that was why I said I was going to do this. Yeah, this will work. It's just... Here was my experiment in my apartment with my camera and my Budweiser bottle cap. Nope, wrong one. I don't know what this is. I think I hit the video instead of the play button. It should be a minute and 16. So this bottle cap My camera is perfectly level. I'll show what this while it goes. I've got a fishing wire tied around my bottle cap, wrapped around the table, and pulling it away from me to sit on my camera. And you will see out there, this is your bottom up, and I'm shooting my camera without changing the height. It's on a tripod. Laser level secure. That's laser level on my table. And so it's gone. So I zoom in. Simply. And now here's a really interesting thing. You remember there was a bottle cap sitting next to it. So I'm going to turn my camera right as I zoom out to that other bottle cap. And you'll notice that the close bottle cap is completely invisible, because I've changed the lens, and now I'm receiving far light and not close light. And then as I zoom out here, I'm looking under the bottle cap, I think already, and there's the bottle cap. I'm going to reiterate that point. Bottle cap is here. There it starts with the mid-boost. So, that little gap of light as I was zoomed in, I was taking all the way under the bottle cap in my camera, ignoring all the light above. The reason that things disappear bottom first is your angular resolution and perspective. It has nothing to do with the shape of the earth. The very first article that ever got me to actually go, what? Was this one. Can I measure the curvature? Oh, sorry, that was for a different bit. So, the very first article that really got me to consider this seriously was this one. Exalt Wireless set a world record of microwave communication. They don't bounce off the ionosphere, by the way. Or else the microwaves that the Apollo ran used to communicate through the ionosphere wouldn't have worked, right? So, anyway, it's a 7 gigahertz microwave system, things that I've installed before. Not so far as this, but I've installed before. And I know as I go a millimeter right, my colleague on the other end is like, I have zero signal. And I've just gone from like 30% to absolutely zero. These are so fine, and I was doing it over like 10 kilometers. These guys have connected this line of sight, point-to-point system over 235 kilometers and are getting fiber optic data network speeds. This was the first scene that just made me go, wait, what? And then this picture, every flat earther will tout you, because it's just so far. This is the Chicago skyline. The very tip of this lightning rod is 527 meters. This is 91 kilometers away. There should be 650 meters of curvature. This is where Joshua Nowicki was taking the picture. He goes across Lake Michigan, and there is the Willis Tower. That is the tallest building. It used to be called the Sears Tower. You might know it by that. But that is the tallest building in Chicago, and that's that one. I used to live in Chicago. I recognize these buildings. This isn't confusing for me. Photographer, not a flat earther. It's a regularly observed phenomenon. It's over 91 kilometers away, and the tallest building in Chicago, the lightning rod tip is what I looked up today, is 527 meters, but that view should curve away from you at 653 meters. There are some who tell me it's a mirage. They tell me it's a superior mirage. And let's ignore the fact that superior mirages are upside down. And let's just talk about what a mirage is and what a mirage isn't. Mirage is where light is coming into your eye that shouldn't be. And it's being affected by probably air and atmosphere conditions. Light coming to your eyes that shouldn't be. Let's reiterate this. This is the Sears Tower. That's the lightning rod. This is the sun behind it. There is a mirage in this photo, and it's the fact that you can see the bottom of the sun twice under the buildings. That's called an inferior mirage. And once again, you'll notice the sun. It's upside down, because that's how mirages work. But you're telling me that a superior mirage, even though it's the wrong shape, is now blocking light, not sending it. That's the opposite of how mirages work. Here's a picture again of Josh. Mirage with that detail and lights is not something that is normally seen. But you're telling me this can be fake. Who is Joshua Nowicki? So let's talk about Joshua Nowicki. Let's talk about this wedding hall in Long High. It's called Dwang 3928. And here's my picture from over 16 kilometers. It's 10 miles. I think it's 16.24 kilometers. You can count them again. We've got 7 stories. We've got trees in front of the base, trees in front of the base, white tip. 1, 2, 3, 4, 5, 6, 7. And here I go from however many miles away. 1, 2, 3, 4, 5, 6, 7. Trees in front of the base, trees in front of the base, the bottom. This should be obscured by 22.51 meters. This is my picture that I took. This is not a phenomenon that regularly appears. I sat there and I watched this building in shadow for 3 hours as I drank on that beach, and then finally my friends were laughing like crazy. The sun hit it, and I grabbed my camera and I sprinted into the ocean because I have to be at sea level, right? If I'm too high, you won't accept it. So I'm literally going, it's a full moon in Boomtown, so it's the lowest tide ever, and I'm sprinting into the ocean with my $500 camera. The friends are just having a good old time. And there it was, and I saw the pagoda there, and I saw the church there, and I saw everything clear as day. Not wrong. Yeah, that one, that's an inferior mirage. I think I downloaded the wrong video twice. Shoot. I have a backup now.
Just in case I did something stupid about that.
That was my proof in case anyone challenged me on what an inferior mirage was. That has nothing to do with my point. Wrong video. It literally was. But I brought my SD card just in case something silly like that happened.
Is that the oil rig or the ship?
That was a ship with an inferior mirage under it. That was not what I intended to display. I do believe that this So here was my view before I zoomed in on my camera, and then I'll show you the video. It's coming from my SD card. It's a little slow. It's too slow. I've closed many of them.
Needs them all.
That building was too many stories to count. So.
$5.
This was about 2:30 p.m., but I've been watching it for 4 hours, and it was in shadow most of the day. I thought the morning would be the best time, but
Oh, I saw this one.
yeah, I just got back from that shoot. My wife was like, great. I was like, how do you understand, Jocko? There's the hotel. There's the wedding hall. I go deeper still, I believe. Let's go back. That my son? Where's that? That's another one. It is so hard to keep the camera still at this speed. That's only 2 stories. There was the wedding hall. Yeah, it was a fast one.
Where are you standing on?
I'm standing front beach in Boomtown.
By like on a boat or something? Because it's
No, that's because I'm so zoomed in. That's me holding my tripod. No, I'm not on a boat. I am on the shore. Look at that.
It's a little shaky.
Look at that. It's very shaky because how zoomed in I am.
Yeah.
So it's so hypersensitive, right?
You lost track of where the train
Those are two-story buildings. They should be obscured by 20 meters of pure.
And people worry about
It's much easier to go.
Don't give your information to the Chinese. Give it to
Josh,
us.
just a quick question. How much time do we still have? Just because
I'm not much longer. Let me take a look real quick.
just taking into consideration that we have to drive home far and
Yep.
stuff like that. I really do not mind doing a part 2 if that will help you condense your information.
I think
I do
that
not think they should-
I'm nearing the stopping point of what I want to go over. So I've covered the meat.
Because then
I think it's just about 30 minutes.
Would you rather stop here and then we can use the time for discussion as well, so that we chat about it and we can do a part 2?
Let me skip and make one point really condensed, and then let's go into discussion.
All right, great. And then we can do a part 2 because
Sure.
this is great.
So, I want to address, because I've shown you a bunch of different equations, going to the curvature should be this, the curvature should be that. And so if you hit YouTube, go and search for curvature, you're going to get all these kinds of videos that say flat earthers don't know math. And that's true in 99% of the cases. But in 99% of the cases of globe earthers, they don't know math either. So I just want to show you guys, we're going to skip that.
So just a question then on that. Then who knows math? If it's not the scientists, and if it's not the...
But the scientists aren't the globe earthers who are talking to me.
Alright,
Yeah.
so then who is your mathematicians? Mathematicians independent from physics, just your peer mathematicians?
So what I did was I verified all of my math in AutoCAD. I built it, literally, and observed it. So I did do it in a simulation, but I did it on the most respected computer-aided design program in the world, on Autodesk 2018, and verified my mathematical equations. And I understand the math so that the people attacking the math, I can explain why what they're saying has some truth and some error to it. And that's what I want to go over. The one that almost, if you just search a flat earther, what they're going to quote to you is 8 inches per mile squared, and very few of them know what that means. This is the actual equation that they're quoting. 8 times the distance squared over 6,360, which is how many arc seconds are in a circle, gives you the amount the Earth curves. But the problem is that draws this parabola. And the Earth isn't a parabola, the Earth is a circle. So this is what most flat earthers will quote you, because this is math that's very easy to do in your head. If you've been studying this for only a few weeks, you can do this equation every single time in your head. This 63,360, I'm sorry, I misspoke. This isn't arc seconds. This is inches to the mile, I'm sorry. This is inches to a mile. So if you do that, it'll give you the curvature in inches, and then you divided it in how many inches are in the mile. I misspoke, I do apologize. This does work for about almost 1,000 kilometers, about 500 miles, but then accuracy gets way wrong. And so flat earthers feel justified in doing this in their head because they're taking pictures like I am at like 70, 90 kilometers. They're not going anywhere near this rate, but it is in fact wrong. I have been using this online calculator to verify my math. Website is earthcurvature.com. The reason I've been using this since the very beginning is because the man publishes his source code. I'm an engineer. I can read his code, and I can make sure he's doing the math that he's telling me he is. So, as I'm calling curvature, I want you guys to understand this right here. This d is the distance of how far over the Earth we're going. And then I'm making a new right arced triangle, a spherical triangle it's called. If you study trigonometric calculus, I messed up on that, but I'm going to keep going. You understand what a spherical triangle or a triangle with an arc is. So this is the radius of the Earth, which I'm taking for master.clef, right? What else? And what I'm trying to constantly calculate is that h. Then there's this other guy who goes, no, that's all wrong. And he's talking about this right here. This was the mathematical equation he did. So he's not totally wrong in all honesty, but I want to explain to you the difference. He's also calculating math, but I want to explain to you the difference where the real variance is of how far. And you need to understand, based on philosophical grounds, as funny as that is, which one you think is right. So let me give you an example. So I've taken this stencil here and I've drawn two arcs at 90 degrees that are perfectly identical, right? Literally, I'm doing this. This is not a computer program.
I watched him.
All right.
Right in front of me.
So here I'm making a right angle on that. And here I'm just drawing a straight line from the two marks. So there are two things to measure. One at about 3 centimeters and one at about 0.9 centimeters. This is called the apothem. This is called the curve draw. Flat earthers use some weird terms because they're very focused on the Earth. These are the equations to get you these values. And the flat earthers call this one the bulge height. So like if we were looking at each other across and we had Superman X-ray vision, that would be how much land we're looking for. Where what I'm calling curvature, I am doing the greater one in all honesty, because I'm assuming you're looking off in the flat lane. That's what I meant by you would be in space already, right? And we should be tilted as we go away. So this is my assumption. And this H right here is what I'm measuring as apart from the apothem. So some flat earthers, and they'll get it to like it's 30% of the value that all the flat earthers get. And everyone, it's just so few people remember calculus and remember trigonometry that it's so easy to just get into all kinds of muddy messes here. They are both valid mathematical equations, but they're different. I wanted to make sure they're different, and I'm going to go through this super fast, but I used AutoCAD, which is a computer-aided design program. And so here I am drawing a perfect circle. So that is under the assumption that the Earth's radius is measured in meters. That's the level of accuracy I did this in. I created a circle in units because it's abstract, right? So AutoCAD doesn't care how big the unit is, it just says how many units do you want. So I said 6,379,000, which is the radius. And I start this arc. And what I'm going to do is I'm going to start the arc at the top of the world. And I'm going to say I want the middle point of the arc to be in the perfect center of the world. And instead of saying how long I want it to go, because it's a curved line, not a straight line, I am instead going to calculate, based on the circumference of the circle, the arc angle, which for something so small comes to 0.89. This is what am I calculating for? Looks like I'm calculating for 112 kilometers right here, which comes to 0.89 degrees. So I build that, and then we see in my AutoCAD this little tiny dot on the top of our world. So we delete the world just to make it easier, and there's our line that we measured. And we're gonna have to zoom in, and it looks straight, and it still looks straight, and it still looks straight. But now I've drawn a line under it, and you can start to see it's a bit blurry. There is a distance there. We just got to keep going. There's that bulge height distance right in the middle point. Right in the middle point of the two. But then, if I take this angle, which before was like this, and then I'm going to rotate it so it's like this, and then I'm going to measure that distance, assuming the right angle the same way. I just rotate the same line that I built, and then there's my measurement over it. So I know that this is a lot of numbers being thrown at you, and I can do this in front of you for any verification, any measurement. The point is like Jacko said, whose math do I trust? I trust mathematicians, because they understand, and they're the first person to admit to you that everything about math is fake. Anyone who thinks math is real, I stop trusting them. Nothing about math is real. And then this is me specifically, I think, these are high-res images. That was dumb of me. I should have made them smaller. But then it's me checking the calculator. I might need to close this and restart. I haven't brought my gaming laptop and it's still struggling. Imagine if I brought GPAs. So here's me verifying this, and that's my only point to make, because what Jocko is saying, how do you know the math is accurate, is so purposeful. So I'm getting 20.51 when they got 20.7. So that 0.39 difference is coming from how many decimals we're going. AutoCAD goes to like the 12th decimal. This calculator goes to the second. So they've rounded off very many things, and the bigger you get, the more that equates. But in my mind, this thinking was enough, and when I take pictures, I always check it in AutoCAD because I don't even trust my own math. Windows 10 calculator is amazing. You can do something like 14 memorized digits after decimal. Remember when we used to pay like $120 for these graphing calculators that are literally worse than $15? Such a scam. So the final point I want to make is I do have predictions and experiments that I want to run. I'm going to do these really quick. There are things we should be able to do. If you can find the perfect equator in the globe model, because it's a ball, the equator should be a perfect circle. In my model, it looks something like this, right? It's a flat projection of the Earth. We still know, so the equator still would even be curved. Another point that I have is if we can go into the southern hemisphere, the farther south we go, the better. So every time Jocko talks about a trip to South Africa together, I get excited. That's really far in the south. So look at this one point I want to make, that if the world is a globe, if we start a certain distance together and both head perfect south, in the globe model we should get closer together. In my model we should get farther apart. This is a test we should be able to do and prove something. What else I got? One really weird thing is the sun doesn't ever change angles and size. The sun sets, it's always the same size. I think that's because of the lens of the atmosphere. So I also have a prediction that if I go up on Fanzabum and I take a picture of the solar filter at the base and then I go up to the top, I should see the sun smaller the higher I go. Because I think the sun is bigger than it really is based on a lensing of the atmosphere. So as I go through the density of the atmosphere, I should see a smaller sun, whereas in a global model, you would see a bigger sun. Also should be the same for the moon. Yeah. Weight at different altitudes. How can we prove that? So there's the end.
Very good. Thanks, Alex. Well, interesting stuff. The public speaker, I'll give you that. Really, yeah. You should be a preacher.
I use their cadence quite a bit.
Same here. That's why they get domestic over.
Yes, it is.
They are very effective.
Yes, it is.
So basically, my comment is I'm not going to comment on any of your content because just purely from my lack of knowledge on this,
Fair
it would be unfair to say anything. But what I do appreciate of this is that I don't think you're trying to convince anyone of anything. I don't see this as a hypothesis nor like you wanted to say if this was a thesis. I don't even.
It's not there yet.
This is just you showing us what you've been researching all
Yeah,
these years,
exactly.
which is awesome. I like that.
I have 4 more years for the thesis at least.
Yeah, absolutely. So sure, I think it's interesting stuff. But yeah, I will take my notes home and I will ponder about it and think about it and do some of my own.
The presentation is riddled with sources if you want the PowerPoint file.
It's just very difficult to find people to help out. Even when I phoned my friend in South Africa yesterday, because he's an astrophysicist, I told him, listen, I need some points on how do you deal with flat earthers? And he, like I told him, he started laughing and he just absolutely refused to even help me.
Mm-hmm.
He said, "Yep, I'm not even going to waste this precious phone call with you to talk about that." He said, "No, let's just talk about what we usually talk about. I'm not going to even entertain that." So I don't even have other people, I can't even turn to physicists and friends who I know are qualified to give me answers because they simply say this is right.
Right.
So
That's why I look down
my
to
advice to you. You'll have to go through that process. You need people with real physicists, mathematicians, to look at this information. And don't get somebody who's going to be out to pick it apart. That will happen after years of research, but you need somebody to not only verify,
I need a
but also
teacher.
falsify your
Yes.
information. Put it through that process. Like I said, get a real PhD person or a person with extensive knowledge in physics, real qualifications.
Well, I guess the next step from this would be to do a lecture and open it to the public. They won't talk to me. I've emailed them.
You have to continue search. I wouldn't advise to throw it to the public. The public is stupid.
It's terrifying. But within 300 stupid people, I might get a smart one. It's my only thought.
I don't trust the public, not at all. Not with these things. There's a reason academia exists. It's called an ivory tower. Yes, it's true. We do sit in our ivory towers, but there's also a reason for that. Research, process, due diligence, the whole process, methods of academia, which you do. I'm not saying you don't, because you are relying on some of the actual scientific methods and philosophical trains of thought. But you said something earlier. You said, for example, it's important for you to look at people like Newton, who was actually trying to continue building on a tradition, whereas Einstein undid that tradition by just throwing in his own stuff.
Yeah.
So I just needed a bit more information on how do you think this is continue building on that tradition.
Well, I think Newton was really surprised by how easy his theorem was to prove wrong. And so that was the point that I probably didn't do justice, but Michelson and Moley and George Airy proved Newton wrong. And so the community was in desperate need because Newton, he said in one letter to assume that objects of mass are attracting each other through a vacuum is a greatest absurdity that I couldn't subscribe it to my own readers. So his point there wasn't that gravity doesn't exist, he invented gravity, right? His point rather was that there is this medium that we have not studied yet called the aether, in which gravitational waves can ripple through. And so what George Airy and Michelson and Moley were trying to do is they were trying to prove the spin of the Earth against the rotation of the aether. And so there's one thing that another phenomena that I didn't get into, but laser ring gyroscopes do read, Foucault pendulum reads nothing, but laser ring gyroscopes do read somewhere between 12 to 16 degrees per hour. And now a real laser ring gyroscope is $30,000, so I'm trusting people in both communities actually on this. There is a flat earther who's gotten one, and his main point, which isn't verified except by video, is that as he goes higher in altitude, the rotation gets slower. So his proof is that it can't be the rotation of the Earth, but it should be the rotation of the aether. But the bigger question is for the globe earthers who say this is proof of the rotation of the Earth, is then in Einstein's general theory of physics, what is the Earth's inertial plane? Because if airplanes and hot air balloons don't need to account for the rotation of the Earth and the Foucault pendulum doesn't actually work, how the hell is the laser ring gyroscope gone? So that's something that adds far more questions than answers in my mind, but it's one of the biggest inconsistencies.
Okay.
Because
and the other two comments, these are more comments than questions. Firstly, you're going to have to somewhere also, for your own research, to protect its integrity, put a line where you are trying to move away from conspiracy theory, because it is still in that realm.
Yeah.
If you seriously want to take this into the world of science, you're going to have to break away. So if the examples you use, the Apollo mission, JFK, I can add things like Hitler's death and stuff like that. It's because there's consensus, even amongst
conspiracy theories
and non-conspiracy theories, that the moon landing probably didn't happen. The Russians didn't believe it.
Right.
Most people on Earth actually don't believe it happened.
Right.
There are substantial information from scientists and even whistleblowers saying, no, it didn't happen. But the same goes for JFK's assassination. There is a lack of, or there is enough consensus on these theories to not make it knowable. It will remain mysteries of history, if you want to call it that. But when it comes to this one, the imbalance between the flat earthers and the globalists is they have a lot.
Smaller than you think.
Yeah,
I didn't quote a single person who agrees with my theory, but there are authorities I could have appealed to.
Sure. And here you are supposed to do that. This is, like I said, this is not a debate.
You think so?
Of course, but the whole
Okay.
point of what the whole tradition is appealing to the authorities who came
Correct,
before us.
correct,
Aristotle was one of them. Nietzsche was one of them. So here, that is the point. Philosophy actually is based on appeal of authorities. And then secondly, this is going to be a tough one for you, is that you are dwelling in the realm of philosophy and in science.
No.
So
That's the only way.
you will have an easier
If
time
you stick to one.
with philosophers, even because they will not be up your ass with things like prove it, science, empirical evidence.
Okay.
For them, it's going to be about the philosophical concepts that you are trying to develop here. And one of the things you're going to deal with is the issue that philosophers are dealing with to this day. What do we do with human limitations? Our limitations of sight, our senses are not the most reliable sources for scientific research.
You're right.
That's why we came up with science.
Right.
So this is where I told you about where Kant and his critique of pure reason comes in. You have to go into your Enlightenment philosophers to bring this out. Nietzsche could be helpful here as well. But in the end, this is going to be very important for you. You need to be able to defend yourself from that philosophical position. To be able to say that we can sometimes rely on human cognitive abilities and use some philosophers and psychoanalysis for that answer. Or you would say that, no, I'm not using just that. I'm using this and this and this. Back it up.
I mean, you're actually probably calling on to an own crisis of identity that exists within myself. Like, where am I an engineer and where am I a philosopher? And my engineering has been since I was 5 years old, and my philosophy has been the past 4 or 5 years. Like, so, you know, it's, I don't know if I clearly know where I stand, in which, how am I, like I showed you, it was the Exalt Wireless publication. That was a white paper done for their customers. That was what got, holy shit. I don't understand pictures, but I understand this technology, right?
So, yeah, you're already on the path though, Josh. You started reading philosophy. You already see yourself going down the Platonic schools of thought. So if you want to be a Platonist, then you're going to have to read the modern Platonists. And all the philosophies that came from Plato, not Aristotle.
Right.
Marx, Weber, Adam Smith, all of these guys are Aristotelians. So that's their tradition stems from him.
But I've always wondered why I draw the line, and after this I want to see if other people have comments, because we're going into stuff that you and I geek out about, but I want to understand where I draw the line between a Platonist and a Neoplatonist. You said something to me the other day about the girl whose pictures in the comments room above. You said, she said, yeah, oh no, she's there, yeah, Pythia. You said that she said mathematics was the language of gods, but Plato says mathematics is the most beautiful art ever invented by man. And that's it. Like, remember, the arithmetic, the first is the study of the abstraction. It might be the greatest gift from the gods, but it's not the language. That's a big difference.
It's our interpretation of their language.
I would accept that one.
I
would accept that one.
It's our writing of their words.
Tesla would agree with that one.
Yeah.
Entirely. You understand 3, 6, and 9. You understand the universe.
And 23. So I like to say, continue doing your work. It's academic, it's research, it's not harming, it's not dangerous.